Hey, in this class we're going to look at evaluating limits. So before we start any question, what I assume you should already know is how to find basic limits. So that could be something like the limit as x approaches 0 of x, and you should already know that this is 0. So stuff like this, and then also the limit as x approaches anything. So I'll just say 5 of 2 is 2. So something like these two questions you should already know how to solve. So if you do not know how to solve them, you should probably refresh up on that before watching this video, because the examples covered in this video are going to be a bit more difficult than you would normally expect. But yeah, okay, so first question, we have the limit as x approaches 2 of x plus 5 over x plus 2. This one is super easy. All you have to do is plug in x into both the x's. So as x approaches 2, so we're going to put 2 in here and 2 in here. So that would look like the limit as x approaches 2 of x plus 5 over x plus 2. Usually I like to rewrite the question because sometimes you can simplify. In this case, rewriting the question was kind of pointless because I wrote down the exact same thing, so you don't have to do it. But this would be 2 plus 5 over 2 plus 2, which is equal to 7 over 4. And that is your answer. So very easy. This works because there's nothing wrong with this number. If it was divided by 0, for example, on the bottom, then we would run into other problems, which we're going to cover in the next example. But for this question, since there's nothing wrong with 2 plus 5 over 2 plus 2, this works and it is correct. So the limit as x approaches 2 of x plus 5 over x plus 2 is 7 over 4. And this is your answer, so we are done. Okay, question number 2. This one's going to be a tiny bit more difficult, but let's try what we did in the previous question. So let's try plugging in 2. This will give us 2 squared plus 2 minus 6 over 2 minus 2. And if you actually evaluate this, 2 to the power of 2 is 4, plus 2 is 6, 6 minus 6 is 0, and then 2 minus 2 is also 0. Okay, this already is invalid because first off, you cannot divide any number by 0. In math, this is just wrong. So we know that we did something wrong, and since we did the actual evaluation right, we know that the step itself was wrong. We didn't do any calculation error, but the actual step itself was wrong, because if you look from the beginning, if x approaches 0 and we have x minus 2 in the denominator, this was going to give us 0 no matter what. 2 minus 2 is 0, so since the denominator is 0, we can't really do much because that's invalid in math. But what we can do in limits is factor and simplify. So this will give us the limit as x approaches 2 of x plus 3 x minus 2 over x minus 2. All I did here was I split off the numerator into these two. I factored the numerator, and now, before we continue, we can simplify this and this, since we have x minus 2 on the top and the bottom, and this would be the same as the limit as x approaches 2 of x plus 3. And in this case, now it's pretty simple, so put the 2 inside, we will get 2 plus 3, which is 5. And yeah, so now this is valid because we're not dividing by 0 like what we had in the beginning. So once again, this is correct because we're not dividing by 0. It's a normal number. There's nothing wrong with it at all. So the limit as x approaches 2 of x squared plus x minus 6 over x minus 2 is equal to 5. I like to rewrite the answer at the end, but you don't have to do this just for neatness and since I'm explaining it so that you guys can understand it better. But yeah, so as long as you write this, you are done, but I like to write the last step just for fun, kind of. But yeah, okay, so that's it for this question. Let's move on to question number 3. Okay, question number 3. The previous two questions were kind of easy because for one of them you just kind of have to evaluate, and the other one was simplifying first and then evaluating. But for this question, it's going to be a tiny bit more difficult because we have to expand this first. Like we said in the previous questions, you first look at the denominator. If it's going to be a 0, that means you cannot do what you would think you should do. So since x approaches 0, you'd put 0 here, but since this would give you something divided by 0, it doesn't matter what that something is, it can be anything. So something divided by 0, we already know that this is invalid, so we cannot continue. We have to find some other way of finding the limit. So already I can tell, okay, what other thing can I actually do? I first look at this cube and tell myself, okay, let's try expanding. And something you have to know when you're evaluating limits is that you're trying stuff blindly. You don't actually know if it's going to work or not, but usually questions are made so that it works. So unless you practice and you notice patterns with questions, there's no other way of actually finding the answer before looking or before trying and seeing what the question will actually give you. So limits kind of involve a lot of guessing. So you just kind of need the experience to be able to know what guess you should approach first. But yeah, so I already know this, but I'm going to write it here. 2 plus x cubed is equal to x cubed plus 6x squared plus 12x plus 8. Once again, I already know this, but you should probably do it on the side somewhere because I did it on the side before the video. But once again, you should do this on the side somewhere because that's what you would get from expanding this. Okay, so yeah, let's actually write this down now. We would have the limit as x approaches 0 of, the denominator stays the same, that we didn't change that yet. And then for the numerator, we would have x cubed plus 6x squared plus 12x plus 8. And then we also have a minus 8 here, so we cannot forget that. So I'm going to write minus 8. And I'm also going to make the fraction longer because we need more space. But yeah, so that's that. That's how we expanded this out. Okay, now we notice, okay, something I can quickly do is, since we have plus 8 minus 8, that turns into 0. So these two go away. Okay, now, if you notice, we can actually factor out an x from each of these terms. They all have an x, so let's factor out an x. We would get the limit as x approaches 0 of x times x squared plus 6x plus 12 all over x. Once again, all I did was I took out 1x from each of these. So that's why the exponent of the x's, it was 3, 2, 1. It became 2, 1, 0. Because all the exponents got decreased by 1 since I factored out 1x. This is basic factoring. I did not do anything special. Okay, from here it's pretty simple. We have an x on the numerator and the denominator. So let's simplify. They both go away. And now we would have the limit as x approaches 0 of x squared plus 6x plus 12. Now, before doing anything, let's kind of talk to yourself. Ask yourself, is this going to be valid if I evaluate it? The answer is yes, because we're not dividing by 0 anymore. So if you just plug in 0 into these, you would get a valid answer. So let's do that. You would have the limit as, actually I'm not even going to write the limit again. I'm just going to go straight to evaluating it. But this would be 0 squared plus 6 times 0 plus 12. And in other words, 0 squared is 0, 6 times 0 is 0, and then plus 12, which is all equal to 12. And we are done. So now I'm going to just rewrite the final answer. The limit as x approaches 0 of 2 plus x cubed minus 8 over x gives you 12. And we are done. Once again, you don't have to write this last step, but I just write it to be neat. But yeah, so once again, quick recap. We noticed that we need to expand the cubed, so we did that. And then we simplified something here. That was kind of coincidence. It's not really coincidence, actually, because the teacher would always give you a question that is made to be solved. So you might think it is coincidence, but the question was made like this on purpose, for you to do this part. Okay? After doing that, it's pretty simple. You factor out 1x to get rid of the bottom x. Our goal the entire time was to get rid of the bottom x, because we don't want to divide by 0. Once we got rid of that, which happened here, then we were able to evaluate it on the spot. You just put 0 into each of these. So 0 squared, 6 times 0, and then 12. And then you actually evaluate it and get an answer. But yeah, so once again, if you think you are going to divide by 0, which we had here, get rid of that division. Once you get rid of it, you evaluate and you're done. So that's it for this question. The answer was 12. Let's move on to question number 4. Okay, question number 4. This one is a tiny bit more difficult because you have to notice a few things. First, what you could do is plug in infinity, because in this case, x approaches infinity of this weird fraction. So you could plug in infinity in the numerator and the denominator. What that would give you, let's actually try it out first. It would give you infinity, which is already weird enough, over square root of 4 times infinity squared, which is also infinity, plus 3, which is also infinity. And then square root of infinity is infinity over infinity. This is undefined. You can already see when you plug in infinity, nothing good happens. So what we should do is get rid of something to stop having infinity on the top and the bottom. Once one of them goes away, you're basically done, because that's easy as that. So there's this trick in limits. Usually when you see a square root, one of two possibilities, we're going to go over the next possibility soon, but one of two possibilities is dividing by x, because you're going to have an x squared inside. So I'll show you what that means, but this is kind of something I know because I've done it so much. So you need practice to be able to know this. But let's say this was a normal fraction and you want to simplify. If you want to get rid of this x, you would divide by x, and if you do it to the numerator, you have to do it to the denominator. So let's do that. Let's divide the numerator and the denominators by x. So we would have the limit as x approaches infinity of, so x divided by x is 1. Once again, you're simplifying. You're getting rid of that x. X divided by x is 1. And then over here, we're going to divide this part by x. So I'm going to write 1 over x, because that's dividing by x, of 4x squared plus 3. Once again, let me recap what I did. All I did was I simplified this by x, so divided by x, and then divide this part by x. But if you divide by x, it's the exact same as multiplying by 1 over x. That's that. So if you understand that part, you are basically almost there. Okay, so the numerator is now a 1, which is good, which is something we want, because we don't want an infinity in the numerator. But now for the denominator, if you are dividing by x, you are dividing by the square root of x squared. So I'm going to write that down here. So the limit as x approaches infinity of 1 over, and then let's change this into the square root of 1 over x squared. I'm going to rewrite that actually a bit neater. But yeah, so square root of 1 over x squared, that is the exact same thing as 1 over x. And then multiply it by 4x squared plus 3. Okay, we're getting somewhere, a bit-ish. Let's see what happens now. This would be the limit as x approaches infinity of 1. And then for the denominator, now, if you know, you probably know this actually, but it's a basic math rule. If you have two square roots, you can combine them up and multiply them together. So what that would mean is this. We would have the square root, kind of like a big, I'm going to rewrite this entire thing actually, but we would have a big square root, and then we would have 1 over x squared times 4x squared plus 3. Once again, all I did was I multiplied both square roots together. So I brought both of them on the inside of one bigger square root. That's it. So from here, now you actually multiply it and see what you get. So this would be the limit as x approaches infinity of 1. And then for the denominator, if you multiply 1 over x squared by 4x squared, you're going to get 4. So square root of 4. And then if you multiply 1 over x squared times 3, you're going to get 3 over x squared. Okay, we're basically done. There's one more step left. But if you notice, if you divide anything by infinity, because once again, we're almost done, you would think, okay, let's try evaluate it. And then it will give you this. So 1 over the square root of 4 plus 3 over infinity squared. All we know is that infinity is a big number, like a super, super big number, but we don't know what it is. If you square it, if you square infinity, you get an even bigger number. We don't really care about that anymore, because as long as it's a big number, that's all we care about. If you have any number divided by infinity, you get 0. This is a very basic rule in limits, but this also makes sense in real life. Let's say you had one pizza, and you wanted to divide it into an infinite amount of pieces. You had the entire planet kind of sharing one pizza together. Do you think they're going to get a huge amount of pizza? Probably not. They're probably going to get like not even a bite of pizza, because you're going to split one pizza into a million or an infinite amount of slices. So each person's going to get nothing, which makes sense. So this number, whatever they're going to get, is pretty much 0. It is close to 0 as x approaches infinity. That number keeps decreasing and gets smaller, and it approaches 0. So once again, I'm going to repeat this. But as x approaches infinity, as the denominator gets bigger, this number approaches 0 and gets smaller and smaller and smaller. So we know that if you divide any number by infinity, you should get 0. That's a basic rule for limits. You should know this. But yeah, so now, since we know that if you divide a number by infinity, it gets you 0, we know that this part is also going to be 0. Because 3 over infinity squared is just 0. It goes away because it's going to be a super, 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 super small number. And now, let's actually rewrite this. So this would be 1 over the square root of 4 plus 0, which is equal to 1 over the square root of 4, because 4 plus 0 is 4. and then this would be 1 over 2. Square root of 4 is 2, and that's it. We are done. This is our final answer. So I'm going to rewrite this now, but now we found out the limit as x approaches infinity of x over square root of 4x squared, not cubed, squared plus 3 is equal to 1/2. And you are done. So, quick recap. All we did was we wanted to get rid of these x's because we don't want to be multiplying and dividing by infinity. That doesn't really make sense in math. So you want to get rid of those x's so that there is no infinity to multiply and divide by. So we divided by x on the top and the bottom. We got rid of the x on top, which is what we want. And then once you divide by x on the bottom, it's kind of like dividing by the square root of x squared. And then you multiply that square root of x squared by the square root you already have. And then that x squared in the inside is also going to go away because x squared on the bottom, x squared on top, they both cancel, and you are left with 4. And then for this constant, 3 over x squared, you just leave it as is. And then after that, you actually evaluate it. We know that 3 over x squared is going to be 3 over infinity squared, which is 0. Because once again, any number divided by infinity is 0. So that's that. And then you have 1 plus square root of 4 plus 0. And in this part from here, it is basic math. All I did was just find the answer. But yeah, so if you understand all this, you understand the answer. So that's pretty much it for this question. Let's move on to the next one. Okay, so last question of the video. If you remember, I said in the previous question, if you see a square root sign, there's usually one of two things to do. The first one, which was in the previous video, was somehow getting rid of the x squared on the inside. So you just divide by x, for example. In this question, that doesn't really work because you don't have a fraction. Usually if you have a fraction like x over root of x squared plus 3, for example, you could actually do what we did in the last video because you can simplify. You can divide this by x and you can divide this by x. But now, it doesn't really work here because if you divide this by x, you're changing the number. It's not even the same question anymore. So you can't really do that. We have to figure out some other way. So usually, the other way of solving any square root involved questions is rationalizing it. So what this would mean is multiplying this entire thing by square root of 9x squared plus x plus 3x. Once again, this is what rationalizing is. You multiply by the conjugate. So, and then this will be over the same thing. So 9x squared plus x plus 3x. And if you're wondering why this works, is that this is equal to 1. If you have the same number over the same number, you're multiplying by 1. So this entire thing is equal to 1. And if you're multiplying by 1, it doesn't really change the question. So this works once again because we're not changing the question. We're just rationalizing it and we're trying to get rid of the square root. So let's try that now. This will give us, if you actually evaluate it, so this will give us the limit as x approaches infinity of, and then now you'd actually multiply the numerators together. That would give you, once again, you can do it on the side, but I already know the answer because it's a difference of squares. This will give you 9x squared plus x minus 9x squared. And then the denominator stays the same. So that would be square root of 9x squared plus x plus 3x. Okay, now we're getting to an answer somehow. Let's try, first notice that 9x squared and then minus 9x squared, these cancel out. So we would kind of do this, and they both go away. Let's rewrite the question with the new information just to make it look nicer for our own eyes and to not get confused. So this would be x over square root of 9x squared plus x plus 3x. Okay, so far we're getting somewhere a bit. Okay, now we're back to the previous question. Because we have a fraction, if you have a fraction, you can simplify. So how do you simplify? You divide top by x and you divide the bottom by x. Let's do that. You would get the limit as x approaches infinity of, let me write the infinity again. But yeah, so of x divided by x is 1. And then this entire thing divided by x, I'm going to write it down here. But it's going to be the square root of 9x squared plus x, all divided by x like this. And then the 3x is going to be plus 3x over x. You basically divide this term by x and divide this term by x. That's all I'm doing here. Okay. After that, it's pretty simple. You actually divide what you wrote down. So this would be the limit as x approaches infinity of 1 over, and then 3x over x, because that's the easy one first. This will give you 3. And then for this part, this is kind of a bit harder, but let's do what we did in the previous question again. So this would be the square root of 9x squared plus x over x squared. All I did here was expanded the square root instead of being only in the numerator to encompass the entire fraction, and I squared the denominator. So because square root of x squared is x. You're basically changing back and forth between these. So I want the square root to be on the entire thing, so I'm going to square the denominator and make it on the entire thing. That's all that happened. Okay. From here, it's pretty simple. Let's do what we did before. So the limit as x approaches infinity of, the numerator stays as 1 because we're basically done altering the numerator. It stays as a 1. We have a plus 3 here. And then for this one, this square root, first let's rewrite down the square root because that's not going to go anywhere yet. If you divide 9x squared by x squared, you're going to get 9. If you divide x by x squared, you're going to get 1 over x. Okay, so far so good. Now we can start evaluating, because you might notice, okay, we have a lot of constants. These are all constants, which is good. That's what we want. And then we have this one term with an x. And if you notice that the one term has x on the denominator, it's going to go to 0 because this goes to infinity. So once again, any number, I'm going to write it here, but any number divided by infinity is 0, no matter what that number is. In this case, if you plug in infinity into the fraction, you're going to have 1 over infinity, which is 0. Once again, imagine one pizza being divided into an infinite amount of people. Each person is going to get almost no pizza. It's a very small amount, it doesn't even count. So now let's actually evaluate this. This would be the limit. Actually, I'm not even going to write limit. Let's actually evaluate it. So this would be 1 over square root of 9 plus 1 over infinity, and then plus 3. This would give you 1 over, once again, this is the square root of 9 plus 0. I'm going to rewrite it down, actually. This is 9 plus 0, and then plus 3. Then from here, it's super simple. This will give you the square root of 9 plus 3 like this. And then from here, this is also equal to this 1 over 3 plus 3, which is equal to 1 over 6. And we are done. This is a good answer. We did not divide by 0. We didn't do infinity over infinity or 0 over 0 because those are invalid in math. And yeah, we got an answer. We're done. So I'm going to rewrite it down here. Our original question was the limit as x approaches infinity of the square root of 9x squared plus x minus 3x. And all that was equal to 1 over 6. And we are done. This is our answer. But yeah, so quick summary of what you should look for usually. If you have 0 over 0, let me write that down again. So 0 over 0, or infinity over infinity, or something over 0, all these are invalid. You have to do something to avoid them. In this case, if you kind of went for it, you would have had infinity. Having infinity is also invalid because it doesn't give you an answer. All you know is that it approaches infinity, but that's not really as descriptive as you would like, so you have to do something else. And plus, you wouldn't even have infinity. You would have infinity minus infinity. So I'm not going to explain that a bit because it's a bit irrelevant, to be honest, but all you have to know is that usually if you have approaches infinity, things can go wrong pretty quickly. So in this case, this did go wrong, and that's why we rationalized to get rid of a bit of stuff. Once again, there's no real explanation on why we are rationalizing. It just comes with experience. So the more questions you do, the more you're going to notice, and the faster you're going to notice that you need to rationalize to get rid of things and to make it easier for yourself. Okay? But yeah, so that's pretty much it for this video. Hopefully that made sense, and yeah, that's it.